Okay, from experiment, from chemical question, we will get molecularity. It is a 100% theoretical concept. But your order na is an experimental value. But your molecularity is a theoretical concept only. Okay, and molecularity have only positive integer value. Means molecularity have value like this one, two, or three, not 1/2, 1/5, yeah 0.5, yeah minus value, not okay. Your molecularity value always like positive integer value. Okay, it can never be negative, zero, or fraction value. Okay, for molecularity sometimes your common example for molecularity is unimolecular, biomolecular, trimolecular. Okay, unimolecular means one molecular, and biomolecular means two molecular, and trimolecular means three molecular. I will explain you how can you get it unimolecular, bimolecular, and trimolecular. Okay, no problem. Okay, and yes, I will tell you one thing in molecularity. In this in these topics, chemical kinetics, normally reaction having molecularity greater than 3 are very rare chance, very rare chance कि your molecularity value more than 3. Okay, very impossible chance. So that is why in our till 12th class, in our syllabus we just study about only unimolecular, bimolecular, and trimolecular. Only in general, na, in general life, bimolecular is very common. Okay, bimolecular is very common. Okay, I will tell you ki how they are forming actually. Actually, what happen if you are doing any chemical reaction, na? So if you suppose that if you have two reactant, okay. So what is the meaning of here bimolecular, trimolecular? I will explain you here. If in a if you doing some experiment, okay, in a container, okay, like this A and B, at a one time, A and B are collide to each other at a one time. That is a bimolecular. Okay. If you are A, B, C, if you are three reactants and they are collide at a one time, A, B, C all together are collide at a one time. That is a trimolecular. And tetramolecular means if you have four reactants, they are collide to each other at a one time. That is a tetramolecular. But you can understand one thing here. Ki two for two reactants is possible. A and B are at a one time. It is possible. But after two, na, three and four, that is very difficult to collide at a one time. You can imagine like this: ki you have a four cross in a road. Okay, you can comparing in the road also. You have four road. Just sorry, 1 second. I think one person are coming. Just 1 second. Who is the KL? Who is KL? Hello. Your class started. Who are you? Can you please tell me your name? Okay, 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 okay. Okay, please see here. Hmm. So I'm telling here, if you imagine if you in a circle is there in a road, if you imagine like this, four road are coming, okay, at a one time, one circle, okay, cars collide in a one road. It is not possible, na? And you can imagine also three from three sides, a car will come and collide to each other at a one time. It is also not possible. Sometimes it's possible, but not 100%. But you can imagine, yeah, for collide, two is possible at a one time. That is why you imagine, if you see, normally in our life, bimolecular is very general, okay, and trimolecular is very less, and tetramolecular, and after that is very rare chance, 1% or 0.1% chance. Okay. Okay, I will explain again. Okay, okay. Please see. I'm saying. If you see in a sometimes in your area, one goal circle is there. Four roads are coming at a one point. Okay, in your area, na, sometimes it happen ki four roads are coming. Okay, at a one point. So you can imagine ki four side car will come at a one time and they are collide to at a one time for to each other. So that is very rare chance. Okay, if you see in a real in a general life, you can imagine कि at a one time four cars are collide at each other. It is very impossible, rare chance. Okay, but two is a chance is very option. Two car collide at a one time. It is normal. But three and four and five, it is very impossible to collide at a one time only. So that is why bimolecular is general. Okay, okay. Here molecularity I will teaching here molecularity Kusi. Okay, molecularity means कि at a one time how much number of reactant will collide to each other for the making the product. Okay, that is the molecularity. Okay, and this molecularity value have positive integer value. This value will negative never negative zero and fractional. They have only one, two, or three only. For very rare chance it will be happen. Okay, and now I'm just see this question. A reaction involving the two different reactants can never be. This question, please see, I think it's coming in 2005 or 2006 AI. Okay, you can see here. A reaction involving the two different reactants can never be involving the two different reactants can never be which option is wrong. Okay, by molecular order is possible. Second order is also possible. Molecular also possible. But unimolecular is rejected. So for two different reactants, unimolecular reaction is impossible. Okay, okay, is not visible. Is a full question here. Is a full question, Tejas. Now is visible. Just one second. That Jose, I just already teach them molecularity, and I write some points here. I discuss with these points with them. Okay, the total number of reactant molecule participate in a reaction to form the product. Okay, if you know in a chemical reaction, sometimes your chemical reaction happen in a one step. So for that the molecule is very easy. But sometimes in chemical reaction you have some two or more steps is there. For that your slowest steps will determine the molecularity. Okay, and molecularity is a theoretical concept. Okay, we will get from the mechanism the reaction. Yeah, sometimes we will get from the chemical equation. Okay, and they have a positive integral value for always. Okay, then it can never be negative zero or fractional value. Okay, and molecularity normally are unimolecular, bimolecular, trimolecular. Bimolecular are very general in the life. Okay, and last point is the reaction having molecularity greater than 3 are very rare chance. Yes, so after than 3 is very large chance कि molecularity is there. So we just in our syllabus only we study only about unimolecular, biomolecular, and trimolecular. And biomolecular we can see so much time. Okay, that is why I am explaining here in the box. कि how can we say bimolecular and trimolecular, tetramolecular. Okay, for this question I already explained. Now I am going for types of reaction. I can s- uh, you can see here a difference. So just tell me na ki what is the difference between the molecularity and order the reaction. So you can see here. Just 1 second. You see.
Sir,
Yes. Yes, please tell me. Yeah, I'm saying this. You can say also study here difference also. Molecule is defined as the number of molecules, here atom, here radicals that must collide in a order for reaction to take place. Okay, I'm saying at a one time, how many number of reactants will collide for happening the reaction. That is a molecularity. Okay, okay, that is I'm saying molecularity. And molecularity terminology like this unimolecular or bimolecular, trimolecular. Okay, I'm already you can see here example. Only in this reactant, only you have only one reactant that is unimolecular. Why? Because in the container only one type of molecule will collide at one time for making the product. That is why it is a unimolecular. You can see here. You can see here two molecules there, H2 and iodide. Okay, then they will collide at a one container to making the HI. That is a biomolecular. Okay, you can see also this one FeCl3, two FeCl3 is there, one NaCl SnCl2 is there. They will collide in a one container together at a one single time. That is why it is trimolecular. Okay, and if you want to the comparison with the molecularity and order of the reaction, you can see here. Okay, just one second. I think someone join now. Just one second. Okay, just one second. Okay, now you can see here difference between the molecularity and order of the reaction. Okay, molecularity can never be zero or fractional. Yes, molecularity always is a one, two, or three. Never be zero, never be fractional. Okay, never be negative. But your order value will be zero, fractional, integer, yeah, negative sometimes also. Okay, because we calculate sometimes order value will come like this 1/2, and sometimes will come negative also. Okay, but molecularity always is integer value, positive integer value always. Okay, and molecularity is independent of pressure and temperature because it's a depend only chemical reaction, yeah, mechanism of the reaction. But your order value depend on the pressure and temperature. Okay, and I already tell you molecularity is a theoretical value and is derived from mechanism, and order of the reaction is experimental value. Is derived from rate expression. Okay, and for molecularity is assigned for each step of mechanism separately. If your reaction will happen in so much steps, so your molecularity will define for slow steps. For slow steps, you can find the molecularity, and for each step, you have a molecularity. Okay, for order of the reaction is not. For one chemical reaction, order of the reaction is only one. It's not depend on the mechanism of the reaction. Okay, and you can see here it is a number of molecule of reactant concentration at terms taking part in elementary steps of reaction. But at a one time, how much molecules are reacting participate? That is a molecularity, and you can see here it is sum of power of concentration in the rate law, yeah, rate expression. That is the order of the reaction. Okay, that is a differentiate between the molecularity and order of the reaction. Okay, it's five and six topics here. I will share, okay, this molecularity and versus order of the reaction. No worry, okay. Yeah, yeah. After class, I will share the notes. Huh? Every time I will do now. I will do of course tomorrow. I just after now class I will share the notes also. Okay. Oh sorry. Yeah. Now I'm coming types of reaction. It's not like this. Please. Now molecularity is complete. Okay. Now I'm telling you types of reaction because this is very important. Okay. Now I am divide the types of reaction on the basis of the timing. Okay. Not okay like average or instantaneous. No. Now I'm dividing the types of reaction on the basis of timing. Okay. Some reaction are very fast. Some reaction in a chemical reaction is very fast. They will take only 2 3 seconds, 5 seconds time for completing the reaction, like ionic reaction. Because ionic reaction, only exchange of the ions will happen, like NaCl plus silver nitrate. If you react, they will make silver chloride plus sodium nitrate. So this type of ionic reaction, okay, this type of ionic reaction, yeah, acid plus base, this type of ionic reaction will happen in a very 5 second, 4 second, yeah, 6 second. So that is why here we do not focus on the time, okay, because this reaction are very fast. Okay. And second types of reaction is very slow, like rusting of iron. You understand, na? Whenever in your home some irons are there outside, and because of 1 year or two, after 2 years, na, they will get rusted. So you can understand they will take so much time for rusting the iron. That is why we call that is a very slow reaction. So for that things also we are not calculating here. Please understand, for chemical kinetics, we are not focusing on very slow or very fast. Why? Because very fast will take only 6 to 5 seconds, and very slow reaction will they will take 1 year, 2 year. Means rusting of iron, they will take so much time, 3 months, 4 months. So here we are not focusing on very slow or very fast. Here we follow only moderate reaction. Moderate means then you have finite time for their completion, which can be measured. Okay, finite time means fixed time. Okay, not a so much time, but is a fixed time you can calculate, you can measure. That for that reaction we are focused on the chemical kinetics only, like moderate. Okay, okay, because in this reaction what happened? 1 second, 1 second. But slow reaction are rate determining steps. No, no. Here means slow reaction means they have only 5 hours, 6 hours. No. Here means कि slow reaction actually comparing to other steps. They are taking so much time. That is why we call slow reaction. But here is not meaning कि rusting of iron. Rusting of iron will take so much time. Okay. Please understand, Harshit. Rusting of iron, like this example, is a chemical experiment. They will take 2 year, 1 year. But here, whatever you saying, na, in a step, in a step, what happen? Ki some step will take 2 hour, 1 hour. Some step will take only 50 minutes, 20 minutes. Okay, from comparing to other steps, if your step will take so much time, that is a slow step. Okay, so that means it's not meaning is a very slow. Okay, very slow means you will take 1 year, 6 months, 2 months, like that. Okay, because in the chemical kinetics, now we are only focused. You can complete the reaction only 24 hours, 48 hours, yeah, minutes, like this. Okay, that is why in a chemical kinetics we are focused on moderate reaction. Okay, because you can find the also answer. Okay, how many minutes or how many hours you can complete this reaction. Okay, that is why we are focusing on moderate reaction. Okay, and now I am dividing the reaction on the basis of number of steps. Okay, a moderate will come na in your chapter na, in your chemical kinetics. Every reaction are moderate. Okay, in every reaction are moderate. Yeah, 5 minutes. Very slow for very slow rusting of iron. That is a very good example. And very fast, like exchange the ionic reaction. Only ionic reaction are very fast. They will happen in a 5 second, 10 second. Okay. For moderate, every in your chemical guidance, whatever we study in a year, na, chemical equation, every year moderate, every reaction are moderate. Okay. On the basis of number of steps. I already discussed with you कि sometimes your chemical equation happen in a one step. Sometimes they will take more than 1, 2 or 3. Okay. But when your chemical equation will take only single step, that we call simple reaction or elementary reaction. If your chemical reaction will happen in a one step, that we call simple or elementary reaction. Okay. For that type of reaction, you don't have any mechanism, you don't have any intermediate. Okay, for that type of reaction, for single step type of reaction, you do not have any mechanism, reaction mechanism, you do not have any intermediate parts, yeah, intermediate reaction. Okay, because this reaction will happen only one step. Okay, for single steps, I'm saying again, for single elementary reaction, your order number, order value, and molecularity value is the same. For simple elementary reaction, your order value and your molecularity value is the same. Okay, please remember that. It is very important here. Okay, the order value and molecularity value is same for simple reaction. Okay, you can. I just draw the graph here. Yeah, I discuss also this points. Order with respect to each reactant is equal to its stoichiometric coefficient. Yes, in a simple reaction, what happen? Whatever the stoichiometric coefficient is there, na, that is equal to also order. Okay, I will give example. No problem. Yeah, yeah. In a simple steps, that is happening actually. I will tell you though. Just wait. Just wait 5 minutes. I will tell you. Just wait. Okay. Uh, I will tell you here. In a simple step reaction, what happen? Your order value is for each reactant is equal to stoichiometric coefficient also for simple reaction only. Okay. Please remember 2 points are very important. For simple reaction, your order is equal to molecularity, and order value for is respect to reactant is equal to stoichiometric coefficient. I will explain here just like this. If you have a one reaction A plus B is become product, you can see uh, power of reactant is also same. Okay, in the simple reaction only. Okay, guys, please just understand this graph. Okay, is a graph for explaining the energy coordinate and reaction coordinate. Okay, for simple step. Okay, this will start and will go, and upper side your energy will go higher, then it will come down, then will you may get product. Okay, please may explain the reaction coordinate is not in your uh, board syllabus. Okay, just understand for this purpose. From reactant to product, your only one transition state is there. Only one transition state. Here, in this peak level, your reactant are converting into product. That is why you coming here and you have got all the product here. Okay, in this step, you don't have any mechanism. You do not have any intermediate mechanism. Okay, not any other steps. Only one step is there, and in one step you convert all the reactant to product. Okay, in this. Okay, now I just explain one question here that you will explain also understand. Please see 2A plus B. These two reactants are making the product only, and these reaction are simpler. For the simple reaction, please see here for simple reaction, whatever the stoichiometric coefficient is there, na, for A stoichiometric coefficient is 2. So you can see here in a rate law, R is equal to K A ki power and B ki power. Whatever the power of A is and B is there is the same as a stoichiometric coefficient. Why? Because I already tell you in a simple reaction, your coefficient, your stoichiometric coefficient, and your order of the value of reactant is same. You can see here stoichiometric coefficient is 2, and in the rate law, A value is also 2, and B is also 1 here and also 1 here. Your stoichiometric coefficient and your order value for each reactant is same. Okay, for simple reaction. Now you can see here. Okay, if he is asking ki volume if will double, so what happen in the two reactant. So if a simple reactant if is given in the question, you can understand, you can write like this: R is equal to K A ki power 2 B ki power 1. So here do not need to find the order of the reaction because already stoichiometric coefficient are equal to order of the reaction. So order of the reaction is here 3. Okay, for A is 2 and for B is 1. So here do not need to find the order of the reaction. Okay, and is asking the volume will be double. So what is the meaning of that? Okay, here what is the meaning of volume double? If I increasing the volume double, that means your concentration will become half. I already tell you in a class कि volume is inversely proportional to concentration. Okay, so if your concentration become half, so you just put here A value half and B value half and their power. If you solve this question, you will get 1 by 8. Means your rate value becomes 1 by 8. Okay, for this question. Now we're going complex fraction. Molecularity is 3, sir? Yes, yes, yes. Molecularity here in this question, yes. Your molecularity is 3. In this reaction, your reaction mechanism is possible. Your reaction intermediate also is possible. Okay. In each step of complex reaction is a simple step. And in this type of reaction, and next point is our molecularity of complex reaction is not defined, but molecularity of is still defined individually. Okay. What is I'm saying here? Key for overall molecularity for a complex reaction is not defined. Okay. For overall, for overall for every steps molecularity is defined. Okay, but not overall. Okay, not overall complex reaction. Okay, it is clear. Okay, and here order is determined from the slowest step. Whatever the slowest step is there in complex reaction, that is determine the order of the reaction. Okay, in this graph you can observe here. In this complex reaction, you can observe here your energy coordinate and reaction coordinate. You can see here from reactant to product, we have two steps, transition steps. You can see in a previous case, you can see only here reactant is there, product is there, only one peak is there. Okay, but in the complex reaction, you can see here two states, two peaks are there like this. Okay, so what is example? Okay, I will give you two examples for complex section. In two example, first I show कि first steps are slow, and the second example I will give you कि second steps are very slow. Okay. For that, how can you do the calculation that I will show here? Okay. Please understand. I also upload in the class also. So please try to understand here. Okay. It is very important for you guys. First example is given 2a plus b become a to b. Harshit, here y-axis is a energy coordinate and y-axis is the energy coordinate and x-axis is a reactant coordinate. I see now here already in a previous graph I explained only energy coordinate here y-axis and x-axis is a reaction coordinate. Okay, कि whenever from here reactant will go like this energy and will become product here. Okay, the x-axis reaction coordinate. Okay, and y-axis is a energy coordinate. Okay, so you can see here. Okay, you can see from reactant to product some steps are involving. That is why we call this a complex reaction. Okay, it's for only general purpose. They will not ask in paper. I am just showing only for general purpose. Okay, so for complex reaction, I will give you example. A2A plus B become A2B, and this reaction will happen in two steps. This reaction will happen in two steps. First step is A plus become AB, then second steps AB plus A become A2B. So this first steps are very slow and second step very fast. Okay. So if I'm saying that here slow, so means these steps, first steps are is a slow comparing to first steps. Okay. Not is a slow reaction. Is slow comparing to only second step only. Okay. So I already tell you is this slow steps. First step is very slow. That is why these steps will determine the order of the reaction. Okay. For these slow steps, you can find the molecularity also, and these steps you can also find the order of the reaction also. Okay. These slow steps they will give you rate of reaction also. Okay. Please understand. These slow steps will give you order of the reaction. They also give you rate of the reaction. Okay. You can see here. For slow steps, you can understand here For stoichiometric coefficient of A is a 1 and B is a 1. That is why I write here R is equal to K into my A ki power 1 and B ki power 1 by, because A constant, A stoichiometric coefficient and B stoichiometric coefficient for slow reaction is 1 1. That is why your order value is a total here 2. And also for the slow steps only. For slow steps only, your molecularity value is also 2. So for order value is also 2 and molecularity is value also 2 for only because of slow reaction. Okay, plus slow step. Okay, if I'm asking, please tell me overall the reaction, overall order of the reaction for chemical questions. I also tell only 2. Why? Because slow steps. If your order of the reaction for slow steps same as the overall reaction. Okay, here is 2. So your order of the reaction also 2. For order value, should we seek stoichiometric quotations? Or yes, in a first simple reaction, if you in a simple reaction, you can assume कि stoichiometric coefficient and order value is the same, and also in a slow steps, you can assume that for simple steps, you can follow कि stoichiometric coefficient and order of the each reactant is same. Okay, and slow steps will also happen. Okay, I just wait for 1 minute. Okay, then I will teach you. Okay, Harshit, just wait. As well, just wait 1 second. If I will give you a second example, then you will understand. Okay, please here. देखो, if your first step is slow na, that is very easy. Okay, you can see here in first from first steps you can get. Okay, Praswal, just wait 2 minutes. I just discuss two examples, then I will tell you. Okay, for your question. Okay, Ashit, just wait. In this example, what happened? Your first steps are very slow. That is why from first steps I got order of the reaction and also molecularity value. Okay, understand it? And here in the slow steps, whatever the stoichiometric coefficient is here, you can put here as a order of the reaction of each reactant. A is a 1, B is a 1. Okay, and you can see in this chemical reaction, AB is the intermediate part of the reactant. If you see here, AB is the intermediate part of the reaction. Okay, so you can understand here, A and B is a reactant, A to B is a product, and AB is a reaction intermediate. Okay, here you can say reactant intermediate because it happens in between the reaction. Okay, I just give you two second example, then you will understand, because second example you can understand why you are saying like this. Okay, please see here, 2A plus B become A to B, but here your first step is not fast, you are not slow. Now your first step is very fast and your second step is very slow. Now how can you get the molecularity and how can you get the order of the reaction? That is very difficult. Okay, that thing will create the problem. So please see here. Okay, in your first step, if you see A plus B become AB, they will mention a equilibrium K1, K2, and second step they are mentioned AB plus A become A to B, and for this your K value K3 is given here. If you want to write the order of the reaction, if you want to order the reaction for this reaction, so now you just write R is equal to K3 because your second step is very slow. You can write R is equal to K3 into AB ki power 1 because AB coefficient is slow step 1 and power of A is also 1. Okay, you can write like this, but I'm telling one true here. It is not true. Okay, for this type of reaction, you can't write like this rate of reaction. Okay, because in a rate law you can't write reaction intermediate AB because AB are coming in a between the reaction. That is why I can't write in a between the in the rate law. So please understand, in a rate law you just write only reactant या product या catalyst, not reaction intermediate. That is why I can't write like this. कि R equal to K3 into AB power 1 A power 1 from slow step, because we are focusing your slow steps are AB plus A. That is why I am writing here. But I am telling you here is not right. Okay, that is I am telling you Harshit, कि if your first steps is slow, then you can follow whatever I told. But if your second steps are slow, then you can't write like this. Okay, then you have to write. How? Please see here. R equal to K3 into AB ki power 1 into A ki power 1. AB can't write in the rate law. Okay, that is why you have to remove the AB here. So how can you remove from AB here? So I will tell you. Oh, please understand here also. कि AB coefficient is 1 and A ki power coefficient 1. That means your order value is 2, not. Okay, for this reaction, order value is also not 2. Okay, so that is I am telling here. Here, for if you want to find the rate of reaction, if you want to find the order of the reaction, if you want to find the molecularity, for that you have to remove the AB concentration here in the rate law. So how can you remove? Okay, why? Because in a rate law, you can't write a reaction intermediate. Okay, reaction intermediate you can't write in the rate law. That is why we are removing from here. Okay, because reaction intermediate is in between the reaction is not a reactant and not the product. So that is why if you are writing the reaction intermediate, so how can I get key AB concentration is like that? Because in a between the it is happening, and that is why I can't write. Okay, that is why in the rate law we only write reactant or catalyst or product only. Okay, that is why here we have to remove AB here. Okay, you can see here. How can I remove AB here? So I will tell you. Please see, first step is a very fast. Okay, if you see here, yeah, first step is a equilibrium. Okay, first step is a equilibrium. So you know the from equilibrium chapter. If I want to express this equilibrium in the equation, so I will use this equation. Okay, so if I want to express this equilibrium in the equation, so I will use this equation. Key, okay, equilibrium concept, and here your AB will come per side. Okay, upon downside is A concentration, B concentration for only first steps. Okay, you can write for from first step. If you study this equivalent chapter, you can get key how can you write this expression. Okay, now you can study here. Now you can see focus here. From here, this expression from here, from concentration AB, you can get here. How? K1 by K2, you just multiply concentration of A and B. Concentration of A and concentration of B just multiply with K1 by K2. So you will get concentration of AB. Concentration of AB is coming K1 by K2 into concentration of A, concentration of B. So now you can now can you put in this reaction? Just say here R is equal to K3 into AB ki power 1. You can now put here AB value. Okay, where whatever the value of AB is here, just put here. Okay, K3 into K1 by K2. Okay, K3 into K1 by K2 into concentration of A, concentration of B, just right here, and already of A is already is there. Now you will get K1 into K3 by K2 is a constant. Okay, now you are get A concentration of A you will get here 2, and B is getting only 1. So now you can find what is the order now, or now order of the reaction is 3. Okay, because A ki power 2 is there and B ki power 1 is there. Okay, for this your order value is 3. But for this reaction, your molecularity value is 2. No, sorry, 3. And because it's slow step, na, that is why. That is why now is the final steps you can say here. Your order of the reaction is 3 because for A is a value is 2 and B value is 1. Okay. Now you can also say it is a molecularity is 3. Okay. And K1, K3 upon my K2 is a constant value. Okay. They will give you in a question. Okay. Whenever they will give you a numerical, I will teach you numerical in a tomorrow class. How can you solve? Okay, this type of numerical. So please wait for tomorrow numerical. I will tell you, okay, how can you solve this type of numerical. So I will upload these notes, okay, in the group. You can note, okay. Please understand. Keep this type of example very tough. So please try to understand this type of example when your second step is slow. Okay. For any molecular order is one. Yes. Order one molecular is two. Sir. No, no, no. Any molecular means your molecular will strike at a one time only one. Na? So if you are, please see, if you are talking about a simple reaction, your unimolecular for unimolecular your order value also one and your molecularity value also one. Okay, but if you are talking about mechanism, I don't know because that is not right for complex reaction, but is right for any molecular order. Your molecularity value is also one and order value is also one for simple reaction only. Okay, not for complex. Okay, complex is for complex different. Okay. I teach numerical on these topics. Okay, tomorrow. Don't worry about that. Okay, I also give you so much numerical about that, and also you can, if you have any doubt in this regarding, I will also explain tomorrow. Okay, no problem. Okay, guys. For unimolecular, na, so unimolecular means your molecular only one. Okay, for reactant, unimolecular means you have only one reactant. Okay, at a one time, your only one reactant are collide to at each other and they making the bond like this. If you see an example here, just see here N2O4. In this reaction, only one reactant is there. So in the one container, only N2 4 are molecules are collide to each other and they make NO2. Okay, that is why it is a unimolecular. So in this case, if your reaction will be in a simple steps, one step, that time your molecularity value and your order value is also same. Okay, so please understand it. Okay, now time just teach only theoretical. Tomorrow I will discuss with the numerical also. Okay, guys, don't worry. I will discuss numerical also tomorrow. Okay, then you will understand properly. Ki how can we do like this question? Okay, in the next class. Okay, guys. I shared these notes in a group in now just after the class. Okay, guys, don't worry. I will. Okay, what you write here, yaar, in Telugu, I do not understand. What is doing Harshit? What are we doing, guys, in message here? Okay, guys. Now I upload these notes. Okay, okay, guys. Now I upload these notes after this class, and tomorrow I will discuss with the numerical. Okay, because of these topics. So no worry. If you have any doubt in this topic, you can also ask from tomorrow in offline class. Okay. Okay, guys. Okay. Now, guys, you can go. Just relax. 10 to 15 minutes. I think your next class is there. Okay, guys. I will upload the notes. Okay, after this class. Okay, guys. Bye. Now we can go, guys. Okay. Yeah, I know up to 4. Yeah. Now it's done. Now. Okay. Now you get your second class. I think for NEET, I think class is there from 4:15. Okay, guys. You can go now. I upload a class. I upload just after the class. Okay, guys. We'll meet tomorrow. Okay, guys. You can go. I I end the meeting. Okay, guys. Thank you. Thank you, guys. Okay, thank you, guys. Bye.
Hello guys. Hello, Vagya Harshit. What's your doubt? Hello, Toy Jaksh. Hello, hello. Can anyone respond? Hello, hello. అవును ఏమైందిరా ఈరోజు తోయ అన్మ్యూట్ చేయి ఒకసారి
చెప్పు ఏంటి?
అదే ఏదో అర్థం కాలేదన్నా
హలో!
ఏంటది ఏమో చెప్పు
అరే
అది
నేను ఆడేదో చెప్తున్నాడు చెప్పనవసరం
ఆ?
ఆడనేదో అడిగా నేను చెప్పనవసరం
ఆర్డర్ మాలిక్యులారిటీ గురించా
ఇంకో బాగా చేయగాడు వీడియో పెట్టాడు
ఆడు ఎలా ఆడుతున్నాడు అసలు
చదివేస్తున్నావు
ఆ? అవును రేపు వింటారా క్లాస్ 6 దాకా 6:30 దాకా
మిస్తో మాట్లాడాను పైకి పంపించేస్తారంట
మాట్లాడావా ఎప్పుడు మాట్లాడావురా అరే ఆడ అసలు ఎలా చేస్తున్నాడు రా అదంతా guys.